Welcome to our next lesson, Unit 13, Lesson 4. And we started with graphing inequalities and situations, worked with 1 and 2 step inequalities, multiple step inequalities. Today we're going to look at some real world applications with the inequalities, where you would see this in real life and how you would utilize that in real life examples. Today, our success criteria. You'll know you have met it if you can independently solve real-world applications of inequalities. Let's get into it. First one here, Sammy has at least. Okay, remember some important words from previous lessons? We are looking for words like at least, at most, less than, greater than, those kind of words. Okay, Sammy has at least 68 envelopes. There's going to be our variable to address. Okay, we know at least 68 and envelopes. Let's use E for envelopes to address. He has addressed 17 of them so far. Let's give that a circle. Write and solve an inequality that describes how many more envelopes at most Sammy has left to address. Okay, well, we know he has to make at least 68. So that's going to be our total. 68 is our total. Okay, we know that he has already addressed 17 of them. If we add to that the rest of the envelopes, how many envelopes does he have to make at most to get to 68? Well, at most means greater than or equal to. So 17 plus E at most is going to be 68. So what he's already done, 17, plus what he needs to do, needs to be at most 68. So this side has to be greater than this side. Okay, let's check it out. Let's solve this inequality. Let's get that E by itself. Well, positive 17, the opposite is negative. We're going to take it away. And we're left with E is greater than or equal to 68 minus 17 is, that's 1, and that's 5, 51. So, at most, at least, at most he can make 51 envelopes. Okay, let's graph this. Okay, let's say this is 50. Let's say this is 51, and so on and so forth. I don't have to number all of them. Okay, we have to use a dot on the number 51, and because there is a line underneath there, that means it is a closed dot. And then our direction, our arrow says that we are going to say that E, whatever number we have to pick, is going to be up this way. It could be any number greater than or equal to 51. Okay, so he needs to make at least 68 envelopes. So if we put 50 in here, 50 plus 17 is 67. 67 is less than 68, so that doesn't work. That's why we cannot pick these numbers down here. But we could pick 51 and up. Let's keep going. Each game at the carnival costs 50 cents. Okay, and we're going to go with each game here as our variable. Let's use G. You can pay $15 total and play an unlimited amount of games. Pretty good deal. Write and solve an inequality to find how many times you should play a game so that the unlimited gameplay is less expensive than playing each game. Then interpret the solution on a number line. Okay? Well, we know that each game costs 50 cents, so 0.5 times the amount of games. So if I play 2 games, it's 50 cents times 2, which is $1. Okay? But we want to find out, when will that number be greater than 15? Because once this number becomes greater than 15, then we should just purchase the $15 unlimited amount. So we want to know, when is that limit? So we need to solve that. Let's get the G by itself. We're going to divide both sides by 0.5, or a half. If I divide both by a half, we cancel these out. We're left with G is greater than, what's 15 divided by 1/2? Well, that's the same as 15 times 2, which is 30. So what does that mean? Let's have our number line here. Okay, we know that we're going to start at 30 on our number line. This is 35, and this is 40. Okay, we're going to get a what? Open or closed circle. Is there a line underneath? No line, so it is an open circle on 30, and we want numbers greater than that. We want numbers that are greater than that. So if I play any amount of games above 30, I am going to spend more than $15. If I play 30 games, I'll be $15 exactly. So it would be the same cost, so it wouldn't matter. But if I played 31 games, 0.5 times 31, that's going to be $15.50. So it makes more sense to purchase the $15 package. It's a lot of games to play. So it means any number. We don't include 30 because 30 would make it the same cost. That's why it is an open circle. Let's keep going. Joe wants to buy some fish for his aquarium. He has $20 to spend, and the fish cost $2.50 each. Okay, we're going to use F for fish on this problem. Write and solve an inequality to find how many fish Joe can afford. Well, he has $20. They're $2.50 each. $2.50 times the amount of fish I buy. So one fish is $2.50. If I put one in there, if I put two in there, it's going to be $5, so on and so forth. And we want this cost to be less than or equal to $20. Less than or equal to $20. Okay. So we got to solve it. We got to get the F by itself. To do that, we divide by, we divide by 2.5 on both sides. These cancel. We get F is less than or equal to 20 divided by 2.5. 20 divided by 2.5, if you want to plug that in, is 8. So how many fish can you buy? We could buy 8 or less fish. Okay, let's put that on a number line. 0, 10, let's make that one 8. Okay, closed or open circle, closed or open circle. Is there a line? Yes, so that means closed circle. And we want less than that. At least, or at most, 8. At most, 8 fish. Let's pick a number. Let's pick 10. Okay, 2.5 times 10. What does that equal? Well, move our decimal. That's $25. Do we have $25? No, we have $20. So that doesn't work. We cannot buy 10 fish. That's why it's not included in our graph. Any number down here would work. You could buy 1, you could buy 0 through 8, and we would be okay. Abby and four of her friends are planning to split a pizza. They want to spend at most, that's a key phrase here, $4 per person. Let's solve a pizza. How many friends total do they have? Okay, Abby and 4 friends. That's 5 people total. Okay, we want to find out how much we should get for our maximum cost of the pizza. Okay, well, we know that they could spend at most. How much could they spend at most? Well, they have 5 people and they want to spend $4 per person at most. So 5 times 4, which is $20. So they can spend at most $20. So the cost has to be less than or equal to $20. Pretty fun one. Let's graph it. 10, 11, 12, 13, 14, 15, and 20. Okay, at most, we're going to put a closed dot on 20 as the line underneath. And we are going to the left. We can spend less than $20, but we can spend at most 20. And our last one here, Sophia can send her or receive a text message for 15 cents or get an unlimited number for $5. We are going to use T for text. Write and solve an inequality to find how many messages she can send and receive, so the unlimited plan is cheaper than paying. This is like that other problem we did up there with the number of games we can play. 15 cents per text message. And we want that. We want to know, when is that going to be greater than $5? Because when it becomes greater than, when T tells me that it's going to be greater than $5, that's when we would switch to that other plan. So we want to divide by 0.15 to both sides. Okay. Well, what is, we get T is greater than 5 divided by 0.15, which is, if you don't know, it's 33 1/3. Okay, well, I can't send 1/3 of a text message, so we have to say that it's going to be somewhere after 33, but we can graph it. So if I was saying in real life, I could say after 33 text messages, then I would go up, not 33 1/3, but I can graph it. Let's say 30 is here. 31, 32, 33, 34, and let's make this one 40 up here. Okay, let's figure this out. Where am I going to put my dot? Well, somewhere between 33 and 34, 33 1/3, which is about right here. And that's going to be an open dot because nothing there. And let's go up this way. So anytime I send more than 33 1/3 text messages, I would go to the unlimited plan, which I think a lot of you send way more than 33 1/3 text messages per month. And just some quick notes here. Solving equations. These aren't inequalities anymore. We have equal symbol here. Okay. If we want to get rid of this 8 at the bottom, this is divided by 8. Let's multiply by 8 to both sides. We cancel them out. The 8's cancel. We're left with -5 plus m equals 8. Then we get rid of the 5 by adding it to both sides. And we're left with m equals 13. Remember, for these problems, we want to start with getting rid of the number here. Okay, we want to start with multiplying by 8 for that problem. You want to multiply by 8 to start with. And let's try here. So we'll notice this first. So the whole numerator is over the 8. If you notice here, the numerator is not over the whole number. A plus 6 is not over 2. Just A is over 2. So we started by up here multiplying by 8 because it was all over there. Here you can't because this 2 is not underneath the 6 as well. So you got to get rid of the 6 first before you can multiply by 2. You get A over 2 equals 6. Then we can multiply by 2 to both sides. And we're left with A equals 12. So on this one, this is A divided by 2 plus 6. So you cannot do that. You want to start with subtracting 6 first. Okay, on this one, because we're multiplying this 3 through this whole term, that's why the parentheses are there. It's going to go use distribution. It's going to go all the way through. We can first divide by 3 to both sides. Okay, with that, the 3's cancel. You're left with x plus 8 equals 36 divided by 3 is 12. And then we get our subtract 8 to both sides. And we're left with x equals 4. Sorry. Okay. You can do either one. You can distribute, or you could divide by the number outside the parentheses. And a couple different notes there that hopefully will help you out, making some problems run a little bit smoother and quicker. Um, that's it for this lesson. Hope you learned a lot, and if you were confused, please post in the comments, go send an email, reach out to me. I'll be more than willing to help. Have a great day, and we'll see you next time.